so we're gonna do chapter 3. Chapter 3 is nothing new. We're just going to kind of like we're reviewing. We're doing a lot of application problems. So I may not even let you guys do, I may not even give you web assigned homework problem. I may just let you guys do a few problems and just do the same kind of problem and do the same steps with the different problems. That's what I'm thinking to do. Because last year I gave them a extra paper homework and a web assigned homework was too much for you guys. So I may not give web assigned homework, just give a paper homework. So you can practice those steps. Anyway, we can look at this problem, particular problem right now. Today's lesson is application of differentiations. So let's look at this problem, particular problem that I have. Y equal to x times x minus 1 times x plus 1. So I have this. So I know there's 3 solutions, right? There's 3 solutions because I can set this equal to, I can set equal to x equal to 0 and then x minus 1 equal to 0, and x plus 1 equal to 0 to figure out what my solution is, right? So you set that equal to 0. Equals to x equal to 0 is the first solution. The second solution would be 1. You add in 1 and you get x plus 1. That's my second solution. Subtract 1, I get x equal to -1. That's my third solution. So I do have a solution right here. So I put the 3 dots. -1 is my solution. 0 is my solution. So my solution is this. If you're asking, and I'm going to say my solutions is what? I have -1, 0, 0, 0, and 1, 0. That's my solutions, right? Because when x equal to -1, that value, that equation becomes a 0. Because 0 times anything is a 0. Okay? And if I plug it in x equal to -1 here, when I put x equal to -1, which is right here, then because of this become a 0, 0 times anything become a 0. If I plug in x equal to 1, and this become a 0, so everything is equal to 0. So looking at this one, let's look at it again. So if I do say when x equal to 0, we get a y equal to 0 times 0 minus 1, 0 plus 1, that's 0. Because 0 times anything is a what? 0. What's the next one? When x equal to -1, you get y equal to -1 times -1 minus 1, -1 plus 1 equal to 0. This case is also 0 because anything times 0 is what? Is a 0. Let's do one more. We already know this. I'm just going over just to see it. X equal to 1, y equal to 1 times 1 minus 1, 1 plus 1 equal to 0 because anything times 0 times anything is also 0. So we know that. Okay, now at this graph, now we gotta figure out, okay, I know I have 3 zeros right there, but I would like to know how I'm gonna graph. Okay, so chapter 3, in a way, we're not using calculator class. Okay, we're not using calculator to do graph, but we're analytically graph. So chapter 3 exam, calculator is not allowed because we're supposed to use our calculus knowledge graph. And calculus knowledge to find a maximum and minimum. We find the most optimized way to save money or save materials. That's what we're gonna do, calculus. So remember the first derivative, we know how to take a first derivative, we know how to take a second derivative. So we're using that knowledge to do application problem. Okay, for right now, I'm not using calculus, okay? I'm just using just simple algebra, okay? So we figured out what x equal to, what x makes the y equal to 0. Can we figure that out? Now we're gonna figure out in this graph, we're gonna figure out, okay, what happened here? So if I Okay, I want to know values. I want to know what, okay, let me use different color. What happened to 2? I would like to know what happened to 3. Okay, I would like to know maybe 0.5. I would also like to know negative 0.5. I want to evaluate those. Okay, so I want to evaluate 4 different values. So let's evaluate. When x equal to negative 2, what do I get? Y equal to 2 times 2 minus 1, 2 plus 1. What is that equal to? That gives me 2 times 1 times 3, which gives me a 6. So at here, we get negative 2 comma 6. So I'm going to come up here and negative 2. I get one number, negative 2 comma what? Okay, I'm into negative 2, but this is a positive 2, so I'm doing a positive 2. X equal to positive 2, you get 6. So that's what I have. So looking at that, okay, that's what I have. Okay, now, let's try a different number now. When x equal to 0.5, what do I get? Y is equal to 0.5, 0.5 minus 1, 0.5 plus 1, which gives me 0.5, negative 0.5, 1.5. This case is easier to just do the fraction, right? So the negative 6 over negative 3 over 6, which is same as negative 1/2. Okay, this is easier to just do the fraction. So you have 1/2, negative 1/2. So over here, you get a negative 1/2. Okay, are you following me? I'm just doing algebra. I'm just plugging in a different x and finding my y value. Okay. So I can graph. Okay, next one. Let's try when x equal to negative half. Okay, I'm gonna just change that into fractions so it'll be easier to multiply. So that gives me positive 3 over 6, which is 1/2. It gives me negative 1/2. I get a positive 1/2. Okay, so I'm gonna also do that over here. Okay. So looking at this, okay, I will do one more, right? Negative 2. Let's try the negative 2. When x equal to negative 2, y equal to negative 2 times negative 2 minus 1, negative 2 plus 1, negative 2, negative 3, negative 1, which gives me negative 6. So I have negative 2, negative 6. So negative 2, I get a negative 6. This is what I have. Okay, so looking at this graph, I can kind of guess. Okay, I can kind of guess. My graph will look like this. Looks like it's going up here and come down, cross the x-axis here and come down here and then go up here and then come down over here. Graph looks like that. But I kind of know, but I don't know exactly because I'm not so sure where does my maximum should be, what the minimum should be. Okay, so look at this graph. I roughly graph this. So remember, I'm not using a calculator. We're just roughly graphing this, just using algebra and calculus. So I'm going to say, okay, I kind of know this graph is going up to the right-hand side. This graph is going down in the left-hand side. But I do not know what this value should be, the minimum. Local minimum. I don't know what this value, local maximum. Okay, why is it called local maximum and local minimum? Look at this value, look at this graph, and look at this value right here. Okay, that's the highest value when you compare to the left. Okay, compare to the left and compare to the right. That's the highest value. That's why it's called local maximum. Are you following me? Okay, what about here? This one over here, and looking at over here, this value here is a local minimum because that's the smallest y value around that to the right and to the left. This value over here is the smallest one. And this is the largest one. When you look at the around them, to the right and to the left, that's the maximum. So local maximum and local minimum, we can find using a calculus. Okay, calculus will give you which one is local maximum and local minimum, and they will give you what x value gives you local maximum or local minimum. So that's what we're going to learn. So we can use algebra to figure out around how it looks like. Okay, it looks like the right tail is going up, the left tail is going down. We know that by calculating so many x values. Okay, now, but I still do not know where the maximum and minimum happens. So that's what we need calculus. So let's do the calculus now. So I'm going to rewrite the problem again. So I have a problem, y equal to x times x minus 1 and x plus 1. Okay, I need to take a calculus. I need to take the first derivative, okay, to find max or mean. We need to do what? To find max or mean, we need to take the first derivative. Okay, and then set that equal to 0 to find x value. That makes the equation equal to 0. All right, so let's do that then. So I have a y equal to x times x minus 1 and x plus 1. First thing, I need to multiply them out. So it'll be easier for us to take the derivative. So I'm going to multiply them out. So I have x equal to, if I multiply those, right, we get a x squared minus x plus x minus 1. So which is the same as x to the third, and that cancel out, minus x. That's what I have. Okay, so everybody with me? I just simply multiply them out. I didn't do anything other than just FOIL and distribution. All right, now let's take a derivative. So y prime is equal to 3x squared minus 1. Okay, so to find, remember right here, if you want to find the max or mean, I need to take what? First derivative, which I did. And what do you do after that? You set them equal to 0. So I'm going to set this equal to 0. And then I need to find the what x value that makes that equation 0. So I have 3x squared equal to 1 by adding 1 to each side. So x squared is equal to 1/3. So x is equal to what? Plus square root 1/3 or minus square root of what? 1/3. So now I know. Okay, now I know where that value should be. Okay, so I'm gonna say, okay, then now because I did this, because I took my first derivative, I know which x value gives me maximum and which x value gives me minimum. Okay, so I have this too. So looking at that, now I can pretty much say, okay, you can pretty much say, okay, this must be the maximum where it happened right here. The x value has to be equal to square root of 1/3. And over here, happen is what? Square root of negative 1/3. Okay, I don't know the y value yet. Okay, okay. If I know x value, can I find the y value? Shalia, how can I find my y value if I know my x value, say square root of 1/3? What do I need to do? Where do
put the y value, put the x value in to find the y value.
Right, so I need to just plug it in. X as what? Square root of 1/3. Square root of 1/3 minus 1. Square root of 1/3 minus 1. That gives me my what? Y value, isn't it? So that means equal to, okay, square root of 1/3 times, in this case, actually kind of hard to do because square root of 1/3, that would be, I guess we could have find it, which case square root of what? 1/3 minus 1, square root of 1/3, this is minus 1, this is plus 1. So if I just multiply them out, well, I can plug it in here. Instead of plugging there, I can just plug in which one? This one, easier one, right? Right here. Right here. So I can plug it in. So when x is equal to square root of 1/3, and then I get what then? Y is equal to the third power minus of that. So I have, that's equal to just the 1/3 times square root of 1/3 minus square root of 1/3, which gives me square root of 1/3, 1/3 minus 1, which gives me negative 2/3 square root of 1/3. That's what I have. So my y value and x value, I have 1/3 square root of 1/3. Don't worry about this algebra, okay? I wanted to just plug into your calculator, and then actually, you know what? I will probably let you guys, I will try to give you a problem that does not involve square roots and things like that. So you don't have to use a calculator. If I give you a problem that involves this kind of algebra that will be harder for you to do by hand, then I will let you guys use your calculator, okay? I will let you know in advance when I make my exam, because I have not made your chapter 3 exam yet. So I will let you know before I give you exams, so you know what to do. So in this case, I know my y value here, because I just figured out that'd be negative 2/3 square root over 1/3. Okay, so I'm not gonna even figure out this part right here because they are reflected to each other. They are mirror image. So I already know that should be positive 2/3 square root 1/3. Okay, so now I'm gonna give you terminology. So listen carefully. So when you take a first derivative, you set them equal to 0 to figure out your x right here. You call it, that's a critical. Excuse me about that. Okay, this x that you found, you call this is a critical number. Everybody with me? You set first derivative equal to 0 and you find your x that equal to 0. okay, that make the y prime equal to 0, that x value, you call it critical number. Now, the critical value means you got to have x and y. So I have two of them. This case is square root of 1/3 and negative square root 2/3 square root 1/3. That's one of them. The other one would be negative square root 1/3 and positive 2/3 of square root 1/3. So everybody see the difference between critical number and critical value. So critical number means you set your y prime equal to 0, find your x that makes that y prime equal to 0. That is just x number, okay, x number. And then when I say critical value means I need x and y, okay, critical point, I will say critical point, that's the what you use in a calculus. So I'm gonna use same terminology, critical point. Okay, critical point. A critical point is it has a coordinates where the x is supposed to be, where the y is supposed to be. So I have to give you exact point where the x and y is supposed to be. So that's why you have x value, you have y, you have x, and you have a y. So on your exam, that's what I'm gonna do. I'm gonna ask you to find critical number and critical point. So which means after you find your critical number, you gotta plug back into your equation to find y values. So you can have critical point. Okay, pay attention class, because this is all the things you need to do to your homework problem and your exam. So by taking a first derivative, we figured out where the maximum is, where the minimum is, okay? Minimum happens at square root of 1/3, comma, negative 2/3 times square root 1/3. The maximum happens at x equal to negative square root 1/3, and y value is 2/3 times square root of 1/3. Okay, now, so we took the first derivative. Now, I want you to, okay, now I'm gonna do, because I'm gonna eliminate using a, just using algebra, but I wanna do everything in terms of calculus. So after you found a critical number, okay, so I want you to draw like a number 9 and point your critical numbers. So this is a 0, so critical number, this is a 1, and this is a negative 1, that's a positive 1, and 1/3, square root of 1/3 should be maybe over here. And here's a negative square root of 1/3. Okay, I want you to draw a line where the critical number is. So this is your critical number, and that's your critical number. I'm gonna call it the critical number. Well, critical number, well, you can say critical value. Critical value, critical value. Okay, you can call it a value, it's probably better. So I'm gonna call it a critical value. Okay, critical value is the x that you found. Okay, now I want you to choose 3 numbers, any numbers between them. Okay, so I will choose one number to the right, and then you need to calculate them. So I will choose x equal to 1 here, and x equal to 0 here, and x equal to negative 1 here. I will choose 3 numbers. Oh, actually, that number that I cannot use, actually, because that will give you zeros, right? You already know that's our critical, that is our solutions. I cannot use those. I mean, if you want to, you can, but it doesn't make sense. So the best number to use is right next to it, which is x equal to 1/2. And here, -1/2, okay? But we already know, we found when x equal to 1/2, what was my y value? We found it here. So what was the y value? -1/2 gives me +1/2. And then this one gives you -1/2. When x equal to -1/2, y equal to +1/2. So, and x equal to 1/2, I have a negative number. Okay, I wish I didn't use the square root of things like that because it's a little more complicated for you guys. So anyway, I'm not going to do this one continue more because it's harder to do calculation using a square root as like subtracting and addition and things like that. But I will do this one, this example, I will do this one Monday. I mean, today's Thursday, so Tuesday I will do it because this I want to use with a national number, like integers instead of radicals, okay? So first thing first, for now, let me moving on to the second derivative. So let me write down our original problem. Original problem was this. And then we multiply them out, that's equal to that. And then we found our first derivative equal to 3x squared minus 1. And then we found that x to be equal to positive square 1/3 and then negative 1/3. That to be our critical value. We figured that out. Now, so we use first derivative to find max or mean. Okay? Now we need to take a second derivative to figure out exactly which one, like which value, which is going to be a maximum, which is going to be a minimum. We know either square root of 1/3 or square root of 1 minus 1/3 will give you the maximum or minimum. Now, I want to know exactly which critical value to become a maximum value, which critical value is going to be a minimum value. To do that, you have to take a second derivative, all right? So take a second derivative now. So when you take a second derivative of this, you get a what? 6x. All right. Now plug it in. So okay, so I'm gonna plug it in. First number, I'm gonna plug in y double prime of square root of 3. Okay, that gives me 6 times square root 1/3. That gives me a positive number. Okay, it's a positive number. Positive y by positive number. Okay, next one, take the second derivative of, and then plug in the other number. Which gives me what? Negative number. Okay, so now let's look at it. I want you to look at this. I want you to look at the graph. So remember, when I plug it in, square root of 1/3, I get a positive number. So y double prime is positive number. So let's see what happened then. Look at my equation. So this part right here, you get a what? Local minimum, isn't it? It's a local minimum. So in other words, the y double prime is positive number then you get a minimum. Okay, are you following me? Y double prime is a positive number. You get a minimum at the critical value. And then over here, what happened then? That is definitely local maximum, isn't it? In this case, as you know, Y double prime is what? Less than 0. In that case, you get a maximum. Okay, so I'm going to come down here. So let me just write down our observation. So what we realize from our observation, so when you have a Y double prime is a positive number, you get minimum at the critical value. And then you get what? When you have a Y double prime is negative, then you get maximum at that critical value. Okay, so I don't even have to worry about which critical value will become a maximum minimum at this point, because I can just take a second derivative to figure out which one is going to be maximum and which one is going to be minimum. Okay, next thing, there is also called inflection point. Okay, inflection point means you set this equal to 0 and figure out what x equal to. You set that equal to 0 and you figure out x equal to what? 0. You call this is a inflection value. Inflection value. If I want to find inflection point, can somebody tell me what I need to do? Inflection point means I have an x and y values, right? So how to find inflection point? Can somebody tell me? I know what, so I got x equal to 0 gives me inflection value, which means second derivative equal to 0. So how can I find inflection point? What do I do with x equal to 0? Plug into which equation? Y prime, or y double prime? Which one do I need to plug in to find inflection point? Ethan, where should I plug the x equal to 0 to figure out the inflection point?
I just got here, so I'm not quite sure.
Okay, anybody else? Anybody was listening? I should ask that. India, where should I put this in?
You said where you should put it in the.
Whenever I'm looking for a point, I need to plug the x value into y equation, okay? So that will give you y value. Because I have x value, I'm looking for y value. So I need to plug this into y equal to this, which gives me also 0. So in this case, my inflection point happened to be 0, 0. Okay, let me review. I know we went over quite a few stuff. So let's review. First thing, how do we find max or mean? What do we need to do? All right, to find max or mean, we need to do what? Answer is what? This is a question, then answer is what? take the what? First derivative. And then what do? Set y prime equal to what? 0. And what? Find x value such that y prime equal to 0. Okay, that's how you want to find it. Okay, by doing that, what's the special name that x value has? What do you call this special name? What are, there's another question. What do we call? Satisfies y prime equal to 0. What is that called? We call that value to be what? When you find y prime equal to 0 to figure out what x number, that number, we call it what? That will be your answer. That's your question. That will be answered. That answer is what? Critical value. And let's see the example. Let me just use a simple example. If I give you y equal to x squared plus 4x plus, say, 3. Okay, I'm gonna use very easy problem. I want to find max or min. I don't even know it has a max or min, but say if I want to find max or min, what do I need to do? What do? I have, this is my equation, what do? I'm gonna take first derivative. So y prime is equal to 2x plus 4. Now what do they say? After you take the first derivative, what do? I need to set them equal to what? 0 to find x value. So I'm gonna set this equal to 0. Then I get 2x plus 4 equal to 0, and 2x equal to -4, then x equal to what? -2. All right, then I just found that special x value, which is right here, x equal to -2. So what does it, this -2, this -2 has a special name. Okay, what's that special name we call? Called critical value. So we call this critical value. All right, next question. Next question. How do we find the critical point or points? What's my answer then? What do? You plot back what do you do? You're gonna say what? Plot critical value into where? Into the original function. Or you can call it what? Y. All right, so what does that mean? So we got y is equal to, what was my y equal to? Y is equal to x squared plus 4x plus 3. So y is equal to x squared plus 4x plus 3. So I'm going to plug it in. X equal to -2. So since x equal to -2 is critical value, So I can put that in, y is equal to -2 squared plus 4 times -2 plus 3, which gives me -1. So now I got critical point, which is equal to -2 comma -1. Okay, are you following me, class? Okay, I will also upload this note on your Blackboard, so you can go over, okay? And then also watch this video today, so make sure that you can do this. All right, so we found so far 3 things. So we found critical number, and then we found a critical point. We found first derivatives. Now, I have a critical number right here, which is -2. And I have a critical point, which is -2 comma -1. But I do not know whether this is going to be my minimum or maximum. I know it's going to be either one or the other, either maximum or minimum, but I don't know. So how should I know which is going to be max or min? That's my next question. Our next questions. So we got 3 and our 4th question here. How do we know whether the critical point will be max or min? How do we know whether it's going to be a max or a min? What do I need to do? What's our answer to that? That is my question again. So what is my answer then? What do? Take what? Second derivative, I should say. Let me just write down. Take the what? You take a second derivative. And then what do? Plug in the critical value to the second derivative. But what does it say? You plug the second derivative, what do you know? Then you're going to say what? If second derivative, the value of the critical value is negative number, then what do you have? If second derivative is negative, what do you have? You have a max or a min? Okay, in this case, you have then what? We have then what? We have max. The critical value is max. That if y value of a critical value is positive number, then what can you say? Then the critical value is what? Min. Okay. All right, so let's see that then. I do have my critical value, critical number. My critical value was, okay, my y is equal to x squared plus 4x plus 3. And my y prime is 2x plus 4. And my double prime is equal to just 2. Okay, my double prime is just 2. So if I plug it in, y double prime equal to, what was my x, -2? Critical value, which is y double prime of -2, is still equal to what? 2, because I have a constant function. Y double prime is always 2. It doesn't matter which value you plug it in. So since 2 is a positive number, since y double prime is 2, a positive number, we have a what? we have a max at x equal to -2. Excuse me, not max. What is it? Mean. We have a mean. Since it's a positive number, we have a mean. Excuse me. We have a mean. Mean at x equals to -2. So let's go over again. We got 4 questions to learn today. How do we find the mean or max? What do? Take the first derivative. Okay, everybody stop writing down for now because I want everybody to understand this. Okay, listen carefully and then talk to me. Okay, how do you find the max or mean? I'm listening, I'm waiting for answers. How do you find your max or mean? What do you need to do? Okay, somebody tell me, what do you need to do? Stephanie, how do you find the max or mean of that equation, the given function? Are you there?
Do we plug it in?
No, how do you find the max or mean? What do I need to do? Take the first derivative. Thank you, Diavia. Okay, as everybody see me, we're going over some questions. I'm asking you questions and I'm also give you answers. So I say, how do you find the max or mean? This is my first question I'm asking everybody. How do you find the max or mean? What do I do? Take the first derivative, you set that equal to 0, and find what? That x value such that the y prime equal to 0 is true. Then I gave you a simple example. Let's use my xy to be x squared plus 4x plus 3. And you take a first derivative of that. What is that? 2x plus 4. So we got it right here. And it says, if you want to find the max or mean, it says take a first derivative and find the critical value, which is we found it. Critical value is x equal to -2. Okay, now Stephanie, that's your second one you're gonna do. You answer my second question actually. My second question is what? I found critical value right here, x equal to -2, but that's just the x value. I need to know my y value so I can have a critical point. So how do you find a critical point? Remember, we have a name that y prime equal to 0 to figure out that, to find the x that satisfies that equation, which is, this case is x equal to -2. So x equal to -2 in this case is our critical value. Now, how do you find the critical point? In that case, what do? We plug it in, that critical value, okay, that critical value, we plug it in, the critical value into my original equation to find the y value. In this case, it's -1. So I have a critical point, x equal to -2, y equal to -1. So in this critical point, okay, I don't know whether this is a max or mean, because your critical point is either your max or either your mean, but I don't know. So how can I go more to figure out whether this critical point will be max or mean? What do? In that case, you need to take a second derivative. Okay, you take your second derivative to figure out whether it's going to be max or mean at your critical point. So you take second derivative and you have 2 rules. If your second derivative and you plug in your critical value and if you get a negative number, okay, if you have a negative number, you get a max. Your graph will go up like that. If you have your second derivative, when you plug into your critical value, you get a positive number, you get a minimum. Your graph will look like this. So in our case, when you have this equation, when you take a first derivative, you get this. When you take your second derivative, you get positive 2, which means your graph, according to this second derivative, you always have a positive, always have a positive. That means the critical point that you found, which is -2, and what was my y value at that point? -1. That one is going to be like this. You will have a minimum always. You see this one? That's your minimum. Your minimum is your critical point, which is -1. So when you have your critical point, the critical point can be positive or negative, but I can tell you right away if I take a second derivative and plug in the critical number into my second derivative. All right, so let's go over on that one more time. Let me give another example. Let's do something easy example again. So if I give you y equal to, say, x to the third to x squared. Okay, let's see. I want to know whether it has maximum or minimum. Okay, I want to know what this graph looks like. Okay, so what we always need to do, take a first derivative. Okay, so when you take first derivative, I get y prime equal to 3x squared plus 4x. And then what do you do after that? I'm going to set this equal to 0 to find critical what? Values. All right, so I'm going to say, okay, that means y prime equal to 3x squared plus 4x. I'm going to set that equal to 0. And I have 3x squared plus 4x equal to 0. The common factor is x, and I have a 3x plus 4 equal to 0, and x equal to 0, or 3x4 equal to 0, and 3x equal to -4, and 3x, and then, excuse me, x equal to -4/3. So I have 2 critical values. X equal to 0 and x equal to -4. Okay, now I'll need to find critical point. So find critical points. Okay, how do I need to do? I need to plug that into my original equation. So my original equation is y equal to, what is my original equation? Y equal to x to the third plus 2x squared. So I need to plug it in, y, and then plug it in 0, which gives me 0 to the third plus 2 times 0 to the square, which gives me 0. So my first critical point is 0, 0. Now let's move on to your second one. Y equal to 3 x to the third plus 2x squared, and I plug it in y equal to -4/3. Remember, this is what I'm doing. So the -4/3, the third power plus 2 times -4/3 to the square, which gives me 64. Well, I can just say 4/3 and 4/3. I'm gonna bring out 2 of them in the front, so it'll be easier for me to calculate. You can use your calculator if you want to. So in my case, I'm just gonna put them in the front. Okay, so I'm factoring out 2 of this. Okay, this is a 2 and this 3, so I'm bringing out 2 of them. So I have a negative 4/3. Okay, so that gives me negative 4/3 square, and that, which gives me, I'm not using a calculator, that's why it's a little bit complicated, but if you use a calculator, it'd be much easier. So I have a 16/3 times 2/3, which will give you 32/9. That's my y value. So my second critical value second critical point is negative 4/3 and 32/9. So I have these 2 of them. Okay, so I have a 2 critical point, but I don't know which one is maximum and which one is minimum. So I need to figure out which critical point would be maximum or minimum. So let's do that. So we found up to critical point. So 4, I need to determine which critical point is max or mean. We need to determine that. So how can I do that? I need to find a second derivative. So remember, your y was equal to x² plus 2x squared, and your y prime, you figured out 3x squared plus 4x. Now take the second derivative. Second derivative gives me 6x plus 4. We're going to plug it in our 2 critical values, right? So we have 2 critical values. What was a critical value? I had a critical value to be what? Remember, we had a 2 critical value 1, which is x equal to 0, critical value 2, which is x equal to negative 4/3. So we have this 2. I'm going to plug it in here. So let's plug in first one, y double prime with a 0, which gives me 6 times 0 plus 4, which gives me 4. Since this is a positive, I know I will have a what? Minimum. Excuse me, I don't know why it does that. So add here, which is the critical point, 0, 0 is a minimum. Okay, now let's do the next one. Y double prime of negative 4/3, it's giving me 6 times negative 4/3 plus 4, which gives me negative 8/3 plus, I'm gonna write down 4 as in terms of 3s, okay? It'll be 12, which gives me what? 4/3. I have another minimum. 2 minimum, that's interesting. Usually you have a 1 maximum and 1 minimum. Did I multiply right, class? Can you look at my algebra and see my multiplication is right? Okay, so you get 6 times negative 4/3 plus 3/12. Okay, so I made a mistake on my calculation. So as everybody see it, it's a negative number. That's what I expect. That's equal to, excuse me, I don't know what's going on here. So that is equal to what everybody see, negative 24 plus 12, which give you a negative 12. So you will have a negative number. So this critical point right here, which is negative 4/3 over 32 over 9, that is your max. Okay, I'm not gonna go over anymore. So I'm gonna stop right here. So we learned today, if you wanna find max or min, you have to take the first derivative. You need to find critical value and critical point. And you need to take a second derivative to figure out which critical point will be a max or a min. That's what we did today. Okay, is everybody with me? Okay, so I didn't do much. Only thing I did is what? Take a first derivative, take a second derivative, using a first derivative to find critical value and critical point. Using a second derivative to figure out whether this is going to be max or min. That's the only thing I did. And then next Tuesday, I'm going to continue this to complete the graph. All right, for now, 4 things you need to do. First derivative, second derivative, critical value, critical point. That's the only thing you have to do. And homework problems, I'm going to just make up homework problem for you right now. Don't worry about doing a Weber sign. Okay, don't worry about doing a Weber sign. So this is your homework. Find critical value, critical point, and determine whether critical point is max or min. Make sure homework is what? Show your work. Okay, here's a problem. Okay, problem 2. Okay, I want you to do this problem. I gave you 2 problems only. I want you to find me critical value, critical point, and determine which critical point is max or min. Okay, that's your homework for today. All right, that's your homework. You only have 2 homework that you gotta do. 2 problems I only gave you. You gotta find the critical value, critical point, and you need to determine which one is max or min. Okay, and I'm gonna continue this on Tuesday to finish up everything that you need to know. And Tuesday, I'm gonna look for intercept, inflection points, and then I'm gonna look at domain and all that, okay? So then we're pretty much done. After that, I'm gonna go over the optimization application problem. So that one, I'll give you homework in WebAssign, okay? All right, that's it for the day. Does anybody have a question that you need to go over? Is everybody clear? Okay, here is the one. I will also put this up in a Blackboard so you can see today's note. All right, you guys, have a wonderful day, and I will see you Tuesday. Okay, if anybody have a questions, you may email me or text me. All right, and also see your PLTL leaders. They're there for you. Okay, go see them and study with them. All right, anybody have any questions? Is everybody good? All right, you guys, have a wonderful day, and make sure you say I'm here so I can do your attendance. All right, have a good day. I'll see you later. Bye.